Intermolecular force or IMF. Molecules are neutral, self-contained particles. They have a specific shape and are made up of compositions of covalently bound atoms. All three stages of gases, liquids, and solids contain molecular compounds, and for those molecules to adhere together, they must have some kind of attraction force. So that forces act between the molecules are known as intermolecular forces. These are the forces that hold molecules together or bind them to other particles such as ions. There are three predominant intermolecular forces. First is the dipole-dipole interaction, hydrogen bonding, and the dispersion forces. Moleculars are polars for two reasons: having polar covalent bonds and having a certain molecular shape. Polarity due to polar bonds. When one atom is covalently bonded to another with a different electronegativity, the electronegative atom draws the electrons in the bond near itself, becoming slightly negative or vice versa. Electrostatic forces are generated between the opposing charges, and the molecules align themselves to increase the attraction, thus reducing the potential energy. Polarity due to molecular shape. When the shape of the molecule causes the charge density to be unevenly distributed, a polar situation is created. So an example of dipole-dipole interaction due to molecular shape can be seen in the water. So as you can see here in the figure, the water molecule is polar because it has bent shape. So hydrogen bonding are caused by highly electronegative atoms. They only occur between hydrogen and oxygen, fluorine or nitrogen, and are the strongest intermolecular force. The high electronegativities of fluorine, oxygen, and nitrogen are created highly polar bonds with hydrogen, which leads to a strong bonding between the hydrogen atoms and one molecule on the lone pairs of F, O, or N atoms on adjacent molecules. Therefore, to have a H bonding, you must have both the H bonded to either fluorine, oxygen, or nitrogen, and the lone pairs of electrons available on the fluorine, oxygen, or nitrogen. So how does H bonding work? So as you can see in the figure, the exposed proton due to the very unequal sharing of the oxygen and hydrogen and the 30% ionic character. The hydrogen atom is very much exposed or naked due to the unequal sharing with the oxygen. The naked proton is attracted to the lone pairs of electrons and other molecules. A temporary association of these two parts of adjacent molecules produces the hydrogen bond.
London dispersed force is caused by random and temporary changes in the polarity of atoms caused by the location of the electrons in atoms' orbital. The location of an electron in an orbital is random. The other side becomes slightly negative. This in turn repels electrons in the neighboring atoms, making this region slightly positive. This induced dipole causes a brief electrostatic attraction between the two molecules or atoms. When an electron eventually moves to another location, the electrostatic attraction is broken and the dipole disappears. London forces are the attractive forces that causes nonpolar substances to condense to liquids and freezes into solids when the temperature is lowered sufficiently. Because of the constant motion of the electrons, an atom or molecules can develop a temporary dipole when its electrons are distributed unequally in the nucleus. While LDFs are generally the weakest of the IMFs, and very large molecules, they can be the strongest. The only attractive intermolecular forces at larger distance presents between neutral atoms and is the major attractive force between non-polar molecules. Without it, there would be no attractive force between noble gas atoms and they wouldn't even exist in liquid form. London forces become stronger as the atom or molecules becomes larger. This is due to the increased polarization of the molecules with larger and more dispersed electron clouds. It also becomes stronger with larger amount of surface contact. This means greater surface area will have closer interaction between molecules. Van der Waals forces is a weak electrical force that attracts neutral molecules to one another in gases, in liquefied and solidified gases, and in almost all organic liquids and solid. It was named after the Dutch physicist Johannes Diederik van der Waals, who in 1873 first postulated these intermolecular forces in developing a theory to account for the properties of real gases. Solids that are held together have a lower melting points and are softer than those held by the stronger ionic covalent and metallic bonds. Van der Waals forces may arise from three sources. First, the molecules of some materials, although electrically neutral, may be permanent electric dipoles because of fixed distortion in the distribution of electric charge in every structure of some molecule. On one side of the molecule is always somewhat positive and the opposite side is somewhat negative. Second, the presence of molecules that are permanent dipoles temporarily distorts the electron charge in the other nearby polar or non-polar molecules, thereby inducing further polarization. An additional attractive force results from the interaction of a permanent dipole with a neighboring induced dipole. Third, although no molecules of a material are permanent dipoles, a force of attraction exists between the molecules, accounting for condensing to the liquid state at sufficiently low temperature.